Hello friends, today we analyze a continuous beam having clockwise rotation at support A, means at support A is a clockwise rotation and that is the 4 by EI at support A, then sinking downward support B by 24 EI, the support is downward by 24 EI, then last is the sinking downward support C by 12 EI. So here sinking of support B and C, and here at A is the initial rotation. So now the procedure that we know, first is to find the Ki, that is the kinematic indeterminacy. So here is a possibility of rotation B support because of internal, and this external support is simply support, that is why also there is a chances of rotation. So here Ki is equal to 2 and that is the IB and IC. Now next is to find the fixed end moment. Consider the span AB as per the procedure. Consider the AB span is a fixed. So like this, 24 at this load is 2 meter. So we know this develop the fixed end moment like this on both the side. So we can say that is M bar AB, that is equal to, first is the minus WAB square by L square. So this value is the minus 12. Then M bar BA, that is equal to, this is the clockwise, so plus WA square B by L square, so this becomes plus 12. Then the span BC, clamp this, we know here this is the load 14 kN per meter. So this will develop a fixed end moment like this. This is the fixed end moment which are developed due to this load. So now we are writing here the fixed end moments that we know. Now this is was anti-clockwise, so minus WL square by 12, so that value is minus 42 kN, and M bar CB, that the plus, so that is the 42 kN. So this second step is over. Now the third step, that slope deflection equation. Next step is to write the slope deflection equation. Slope deflection equation. So again consider the span AB. Here is equal to 4. I is equal to I. Then important is the delta. So delta is equal to always the leading joint first. So delta B minus delta A. So we know here delta B is the given in the equation. Delta B here given is 24 upon EI. 24 by EI. And delta A is nothing given, so that is 0. So delta is 24 upon EI. Here also the I is given, the initial rotation clockwise. Here clockwise rotation initial is given 4 by EI. So I is given 4 by EI. So M AB, that is equal to, we know, is m bar AB plus twice EI by L into, this first is A, so here twice IA plus IB minus, now here I is given, that is 4 EI by L, IB is, that is the unknown displacement, delta is given. So now put all this value, m bar AB, that is the minus 12, here plus 2E L is equal to 4, here 2 into 4 by clockwise is positive, here is a rotation is clockwise, that is why is positive, plus the IB minus 3 delta by L. Here, now here put value minus 3 by 4 into delta is 24 upon EI. So minus 12 plus, multiply this in bracket, so this becomes the what? This 4 gets cancel out. So this remain here the only, this EI gets cancel out, right here the steps like 2 EI by 4 into 2 into 4 by EI plus here the 2 by 4 EI IB minus 2 by 4 EI, 2 by 4 EI into 3 by 4 into 24 divided by EI total. Now here this EI gets cancelled out, this 4 get cancelled out. So here is what, minus 12 is 2 into 2 plus the 4, then here is plus EIIB by 2, here minus, so this calculation is the, this EI gets cancelled out, and this calculation is the 2 by 4 into 3 into 24 divided by 4, that is the 9. So this is 9, so this becomes the 12 for this 21, this becomes minus 70 plus 0.5 EIIB, this is equation 1. Then we go for the equation BA, so that is the here m bar BA plus twice EI by L into twice IB plus IA minus 3 delta by the L. So here is a plus 12 plus 2E L is equal to how much is 4 twice IB, here plus I, instead of I is a 4 by EI, then minus 3 by 4 into 24 upon EI. Now if you solve this, so this final value is the 5 plus EIIB. So this is the equation 2. So span AB is over. Now go to the span BC. Now span BC, here I is equal to I, L is equal to the 6 meter, then delta is equal to, important is here what, leading joint is the first, so delta C minus delta B. So we know here delta C is 12 by EI minus delta B is a 24 upon EI. So this becomes minus 12 by EI. So we got the value of delta is equal to minus this 12 upon EI. Now MBC is equal to M bar BC plus the twice EI by L twice IB plus the IC minus delta by the L here. Now M bar BC is the minus 42 plus here twice EI by L is equal to 6 twice IB plus the both are the unknown displacement hour, so there is some value, so minus here 3 by L is 6, delta is equal to minus 12 by EI. So in this way, so this minus 42 plus this becomes the 2 by 3 EIIB, this becomes plus 1 by 3 EIIC. Now here this is minus and this is minus, so becomes plus here 2 by 6 EI into 3 by 6 into 12 by EI, this value. So this EI gets the cancel out, this 3 and this 2 6 gets cancel out, this becomes a 2. So here minus 42 and this is a plus 2, so this becomes the minus 40 plus 2 by 3 EIIB plus 1 by 3 EIIC. Then MCB, so this is equation number 3. MCB is M bar CB plus twice EI by L in bracket twice IC plus the IB that we know here 3 delta by L. So this is a plus 42 plus this becomes the 2EI by 6 into twice IC plus the IB minus here 3 by 6 into minus 12 upon EI. So this becomes 42 and this is value is a 2, so that is the 44 plus 2 by 3 EIIC plus 1 by 3 EIIB. This is equation number 4. So we got the equation 1, 2, 3 and 4, and the next step is to apply the equilibrium conditions. So next step is to apply the equilibrium conditions. Equilibrium condition, that is sigma MB is equal to 0 and sigma MC is equal to 0. Why this? That we know already in the previous lectures. We have seen this. If this is IB, so here is a sigma MB, this is IC, here is a sigma MC. So there are the two conditions of the equilibrium. So at the joint B, BA and BC is the moments. So MBA plus MBC is equal to 0. So MBA is phi u plus EIIB, then BC is the minus 40 plus 2 by 3 EIIB plus 1 by 3 EIIC is equal to 0. So this becomes the 5 by 3 EIIB plus 1 by 3 EIIC is equal to minus 35. This is equation A. And second condition is sigma MC is equal to 0. So at the C is only the MCB is equal to 0. Only here the moment is MCB. So MCB is equal to 0. So our MCB is the 44 plus 2 by 3 EIIC plus 1 by 3 EIIB is equal to the 0. So this becomes 1 by 3 EIIB plus 2 by 3 EIIC is equal to minus 44. This is the equation B. Now if you solve both this equation, A and B, will get the value of EIIB is equal to the 38 and EIIB IC is equal to minus 85. Now put this value in equation 1, 2, 3, 4. These all equations 1, 2, 3 and the 4. So now put this value EIB and EIC in the previous equation. So this minus 17 plus 0.5 into this EIB. So we got this, the final value 2 kilonewton meter, 43 kilonewton meter, minus 43, and the at this last end there is a 0 because of simply supported. Now next is to Benderman diagram. So here what? First draw consider beam as simply supported and draw the Benderman diagram. Now first is the value is the plus 2. So apply this clockwise. So this creates this upward attachment hogging. So that is why here this is the 2. Then MBA, that is the plus 43, plus means clockwise. So apply here clockwise, and MBC also the clock and is minus means anti-clockwise. So here apply the anti-clockwise, and this is the 43. So what here? So these both are creating the hogging movement. So take it here, suppose it's the 43. Then last one is the 0 because of simply supported. So join all these points. So this common part gets the cancel out. This is plus, this part is minus, plus, this is minus. So here is a 0. So this is the final BMD. Thank you.